So continuing on with the nice little roller coaster question, look how this is different from the previous question. In this question, it says, okay, use the equation from example 6. So I'm going to write that equation down. V equals to the square root of V naught squared, okay, plus 2AD. All right, so I bet you this question is going to ask us to find something else in here other than D. Okay, it says a roller coaster has a vertical drop of 34 meters. Remember, that's a distance, so guess what? They've now told you that this is a 34-meter drop. But wait a second, wasn't the last question in feet per second? And in feet? And feet per second squared? Yeah, but look, now everything's in meters, meters per second, and meters per second squared, which is a beauty of some, not all, physics formulas, is that you can bounce back and forth between imperial and metric. Want to prove it? Go ask your physics teacher, huh? Okay, now, acceleration due to gravity is 9.8. Okay, so there's the 9.8. Beautiful. You need a 2 there. Perfect. V naught squared, what are you talking about? Well, that's what you're trying to find. What's the initial velocity? Okay, so there's your V naught squared. So that's the guy you're going to solve for. This is all square rooted. And your velocity here at the bottom is 26 meters per second. So there's your 26. So this makes it a little bit more interesting to solve. All right, so what? Let's go out and solve this. Not a big deal. All right. So start throwing stuff in your calculator and start cleaning this up. Okay, first thing I'm going to throw in there is this. So 2 times 9.8 times 34. Let's see what that number is. 2 times 9.8 times, what was it again? Was it 34? It was 34 equals this number, 666, oh, sorry, 0.4. You don't know what the growling's all about? Go to Sunday school and figure it out. Okay, so this is 666.4 plus, V naught squared. Huh, that's weird. Okay, that's all square rooted equals to 26. Well, how do we solve this guy now? Becomes a little bit of a problem, doesn't it? Not really. Get rid of the radical. Square both sides. Oh, easy peasy. Okay, let's go back to our calculator here, and let's go 26 squared and see what we get. 26 squared works out to be 676. Interesting. Okay, so this is 676 equals to V naught squared plus blah, 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 0.4. Okay, now simple algebra from this point on then means subtract blah, blah, from each side. There it is. Okay. That's gone. Well, go out to your calculator if you can't do this in your head and just go, okay, I want this guy here, enter, subtract this guy up here. Now, I'm showing you this because what if the numbers were ugly numbers? Like, I mean ugly with huge, huge decimal places and stuff like that. Now you know how to use your calculator to your advantage to find out what that number is. Oh, 9.6. Boy, that was tough. So this is 9.6 equals to V naught squared. And look at this. Square root, V naught equals 2. Should be something a little bit more than 3. Okay, so second square root of this answer here. Boom. And your result is, yep, 3.09, or basically just good old 3.1. But don't forget, go back to your question now and see a couple things. Talk to your science teacher and they'll tell you all about significant digits. They're all, if you look, all are 2, right? And this is, of course, in meters and meters per second. Now, look what you're trying to find. You're trying to find initial velocity. So this is 3.1. There's your significant digits and meters per second. You are done. Okay, now you could go out technically and figure this out on your calculator. Why not? Let's do it. I would probably go from this point here and say, okay, I've got 26 equals to the square root of V naught squared plus blah, blah, blah. Okay, 666.4. There's my y1, there's my y2, and I plug it in. But again, think about this. This is 26. That means that your y max should be somewhere greater than 26. Make it maybe a 30. And you know that this, which is your V naught, is around 3. So you can actually leave the X max as a standard, what we had in standard position of being around 10. Okay, so a little bit of pre-planning and courtesy of algebra, right? Okay, so let's throw that into our calculator right now. Okay, so put the y1 26, the y2 is that. Let's see what it looks like. Ah, there it is. Okay, go back to your window setting because remember, this was set on the other question now because that was in feet per second and feet per second squares. Now we're dealing with meters. So we said that their X max should be around 10 and the Y max, because this will be a really wonky graph, we should have this probably somewhere around 30 and that should give us a really nice result. Graph it. Oh, sure enough, there it is. But you'll notice something that's interesting here. You've got an intersection over here and you've got an intersection over here. Think about this. This is physics now, and we're talking about velocities, initial velocities. You don't want your velocity to be negative because that means you're going backwards. So in other words, you're actually trying to find that point right there. So second calc then, find your intersect 5, and let's mouse that guy a little closer to where I want to go, which is way the heck over here somewhere. Hit enter, 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 and look at that. There's our velocity as we predicted at 3.09. Remember, you don't care about the y value, okay? So 3.09, somewhere around 3.1, there's that. We know that our initial velocity is about 3.1, and check this out, meters per second, and that verifies with your algebraic answer there. Nice question, eh? Great way to end the unit.